Now, this is actually, so this guy is just all about algebra and rearranging some of the equations we already have. So first off, let me remember, so from before we had v minus v initial equals at, or I can write this as t equals v minus v initial over a. Now, I'm going to substitute this into equation 2. So remember, equation 2 was that x is a half v plus v initial times t. So I'm going to make this substitution for t. So I'm going to get x is 1/2 v plus v initial, and now instead of t, I'm going to write this as v minus v initial over a. Alright, so now let's work on cleaning this up a little bit. So let me multiply both sides by an a, which gives me an ax on the left. Let me multiply both sides by 2 to get rid of that 1/2. So I'm going to have a 2ax. So, and this is going to be v plus v initial, v minus v initial. Now, if you remember your algebra, when you have something that looks like a plus b times a minus b, that's equal to a squared minus b squared. So that's exactly what I have over here. So I'm going to have 2ax is v squared minus v initial squared. Okay, so let me add a v initial squared to each side and reverse things a little bit. And so I'm going to get v squared is v initial squared plus 2ax. And that is kinematic equation number 4. Okay, so just to summarize what we have, we're going to have equation number 1, which says v final equals v initial plus at. Equation number 2 said that position x is 1/2 v plus v initial t. Number 3 says that x is v initial t plus 1/2 at squared. And finally, equation number 4, which is v squared, is v initial squared plus 2ax. Okay, so those are our 4 kinematic equations, and just one little note here, your textbook does write them slightly differently, but basically if you don't assume that x initial is always 0, then all you really need to do is you need to substitute everywhere you see an x in these equations. Instead, you put in an x minus x initial, and that'll actually get the book version. Similar sort of thing, you could imagine that you didn't choose 0 for t0, and again, if you don't do that, basically everywhere you see a t, you can put a t minus t initial, and that'll tell you exactly what to do if, for whatever reason, your t initial isn't 0. So remember, here's our 4 kinematic equations, and of course, most important assumption that went into these was that acceleration must be constant. If your acceleration is not constant, then these kinematic equations are not going to apply, so you're going to have to figure out something different.